right, everyone, thanks for joining me again. This is the homework video for worksheet 1-7 for the class Discovering Exponents. And in this video, I'm going to be turning these into radical exponents, okay? So I'll show you what that means. Remember, it's taking the fractional value of the index, okay? So we did a little bit of this in class. I usually express it from both ways, from the exponential way and the radical way, but it's very important to be able to write it from the radical way. I just show it the other way in class to help you with that process. So we're going to be doing that in this video. Okay, so if you are not in this class, but you would like to learn this skill, no worries. You can look in the description below and you can see a link for the class and sign up. Okay, give me 1 second. I'm going to throw these answers up on the board now. All right, so there's the answers. Go ahead and check your paper. Pause, because I'm going to go on, all right? So go ahead and pause. I'm going to assume you have now. I'm going to switch my view so that it's closer, because that's teeny tiny writing and I have bad eyesight. So basically, in the last homework, you were doing opposite operation, okay? And the opposite operation of doing this would be a square, right? Well, yes and no. It would be, but then I'd have to solve it too. I'd have to have something over here on the other side of the equals. I don't have that in this case. There is no equality, so I can't do opposite operation. If you were like looking at this worksheet and say, hey, I do opposite operation. You can't, because there's nothing on the other side of this equals. Remember, opposite operation only works when there's a balance of equality in the equation. Again, if you're having trouble with your algebra skills, watch that video. I usually put a video on algebra skills in the classroom. I also have tons of one-day-only crash courses. Make sure that you're looking those up as well, or just contact me and I'll see what I can do to help you out with it. But in these, we can't do opposite operation. We are rewriting the expression, okay? So let's talk about an expression real quick. I know I have in class, but these radical expressions. So this radical says what times what equals 64, and the answer is 8. So the answer to this is 8. And if you put 8, you're doing pretty good, okay? Well, there is another way that I can do this. I can rewrite the following radical as an exponent, okay? Now I could write it as 8 squared, and that would equal 64, but it wouldn't equal the square root of 64. So this is how we do these. I'm going to leave that. I'm going to show you how to do it, showing you the exponential form. So the exponential form is 8 squared, which equals 64, but it doesn't equal the square root of 64. What I'm going to do, though, is show you all an exponent is repetitive multiplication. So we can use the opposite operation rules to derive how we write this. It isn't the actual process, because again, this isn't the square root of 64. The opposite operation would actually be the square root both sides, and that's how we would derive 64. But I'm showing you how this concept came to be, that I can use a 1/2 power and it would give me the same answer. I can divide over here by a 2. Well, this 64 has a power assumed of a 1. So if I divide this power by 2, I can also divide this power by 2. So if I wanted to just rewrite this, I'm not trying to solve it, I'm not trying to do opposite operation, I could just take this, and basically what I'm doing is writing this square root, taking the 64 and rewriting the square root as an exponent. The square root, if I rewrite that square root as an exponent, it's 1/2 power. All right? So that is how all of these will go. You're just rewriting the square root as a 1/2 power. And I'm not going to go through and write them all out. I kind of explained it in this first one, and you can rewind and listen to that explanation again. I am going to hit up one more because it's pretty easy. You just write what's underneath the radical to the 1/2 power, because what we're doing is we're rewriting that radical as an exponent. I'm going to hit up this one though, number 8, and I'm going to do it again. So to rewrite, and you can check this on your calculator, and it's super duper easy if you check it on your calculator. And actually, let me show you. Okay, let me get my calculator up on the screen, and I'll show you. So let's look at 8 on a calculator and compare. So I could take the square root of 364, which on this one I have to go 324 and then square root it. And look, the answer is 18. So if I were to find the answer of this, it would be 18, right? Okay, let's look at it if I write it, if I do the question in the exponential form. So in this one, I'm going 324, and I'm hitting this bad boy button, and I'm going to put this exponent in parentheses. See how I use the divide symbol? Because a fraction is division, okay? So it's 0.5, that's what the 1/2 is. So I'm going to do this, and oh, look, I get the same exact answer because it's just two ways of writing it. Okay, they're both the same. They're going to give me the same answer because they both mean the same thing, okay? Taking it to the 1/2 power and taking the square root of it is the same exact function. It's just two different ways of writing it. And what we're learning is the two different ways of writing it, because when you get to logs, you can solve logs using very different techniques. And logs is getting to that level of math where I can't just give you every single situation you might run across. You solve everything slightly different than the last problem, so you need to know all the tools to be able to apply what is needed for that situation. So I've got to teach you the different ways we can write a radical, the different ways we can write an exponent, and that's the meat of this class, that and learning the rules of exponents. And then polynomials, okay, because we run into some polynomials in logs, okay? So again, it's just rewriting it in a different way. We're not solving anything. We're not doing opposite operation. All of these was just rewriting it in a different way. So now I want to do question 9. Okay, so question 9, I have a cube power. Okay, that means what times what times what equals 8. If you know anything, you know it's 2 times 2 times 2 equals 8. So this is like the same as 8 to the 3rd degree. It's a cube root, 8 cubed. Okay, well, opposite operation would have been to cube root both sides if I had an answer on the other side, which I don't. We can only do opposite operation if I have an equal sign with an answer. Okay, so what are we going to do with this? Well, I can write this expression in a different way. And the way that I do it is I just divide by 3. Okay, so now that 8 has an exponent of 1. I got to divide by 3 there. So saying the cube root is the same, these two expressions are the same. They're equal to each other, okay? They're both saying the same exact thing, all right? So all you're going to do is rewrite it to the 1/3 power. All of your cubes are rewritten to the 1/3 power. I'm going to do number 11 on a calculator so you can see they're the same exact thing, okay? So I need a cube root. Oh, I'm not sure about this calculator. Oh, here it is. Okay, so I'm going to do, I'm not quite sure how to do this, so let me just play. Oh, I don't think that's how, okay, I think I have to go 364. Nope. I love it when technology does not work with me, so I have to find a different way of doing it last minute. Okay, so on this computer, because my Texas Instrument app was not working today. On this computer calculator, what I have to do is hit 64, then my root, and then I have to hit what the index is to my root, and it tells me that the answer is 4. So when I take the cube root of 64, the answer is 4. So let's see what the answer is when I take 64 to the 1/3 power, all right? And if it's not the same, then I can't write it these two different ways. So let's see what happens. 64 to the, I'm going to do parentheses, 1 divided by 3. And I get the answers of 4 as well. Look at that. They both got the same answer because they're just both the same. They're just different ways of writing the same exact thing. All right, I'm going to do 12 and 14, and then that will be it for this one. So again, we're doing that opposite. We're going to divide by 4 to get rid of the index, and we have to divide by 4 under the hat too, which will just leave me, this is all going to cancel out, and leave me with just 16 to the 1/4. So these are equivalent. I can write it like this, or I can write it like this. They both say the same thing, okay? So the answer to another way of writing that is 16 to the 1/4 power. Now let's do it in a calculator so you can get that contextual visual, I believe you. Okay, so I got to go 1296, hit this bad boy and the 4, and I get an answer of 6. So the quad root of 1296 is, what was that answer, 6? Yes. Now let's solve it as an exponent. 1/4. All right, so I do 1296, hit my little exponent button, and I'm going to do comma 1/4. All right, and I also get the answer of 6. So obviously, yes, these are both going to get you the same answer because they're two different ways of writing the same thing. I hope this video helped you with the homework. Let me know if you want some more explanation on one that I did not do, and I will see you guys in class.